Welcome back. We are discussing about some videos under environmental engineering. In this video, we'll talk about water quality standards. The water quality is more important, and there are some standards for different purposes. One given by IS code, Indian standards for drinking water quality, and the another one is WHO, World Health Organization for drinking water. And besides that, this water quality we can also have for construction purpose, industry purpose, as well as for water quality based on usage point of view. So let us see one by one. This is the permissible limits for drinking water. This is code is based on IS 10500 2012. So these are the various parameters. Physico-chemical characteristics. There are two categories of limits here. One is acceptable limit, another is permissible limit in absence of any other alternate source. So this particular column, the acceptable limit here is considered as the limiting parameter, and only in the absence of any other source we go for the last column. So you can see here color, odor, pH, taste, everything is there. So pH is the most important thing, 6.5 to 8.5, and for the both acceptable as well as absence of any other source. The turbidity, if you see, ideally it should not be more than 1 NTU, effluometric turbidity units. But in the absence of any other source, you can be relaxed up to 5 NTU. Similarly, TDS, if you see, total dissolved solids. So here, ideally, it should be less than 500 ppm or milligram per liter for drinking. And it can go up to 2000 milligram per liter in the absence. Similarly, total hardness. Okay, so 200 milligram per liter as CaCO3 and 600 in the absence of any other source. Similarly, some of the other physicochemical characteristics, including heavy metals, the cadmium and all those things. Here, if you see the acceptable limit and the limit in the absence of any other source, both are same. That means, so the parameters are so important. There is no relaxation for this type of impurities. The bacteriological characteristic, usually we talk about E. coli, coliform bacteria, and they should not be detected, most you can see here, for treated water distribution systems. So nothing should be available. That is what it is. So these are the WHO standards, 1993 issued. So the limited parameters are issued under WHO when we compared with that of the IS 10500. Some other parameters are given, but they are not of much significance to us when we compare with the conventional drinking water quality standards. So you can see here the turbidity going up to 5 NTU, total hardness is going up to 500 here, whereas the IS standard gives only 200 maximum. Similarly, TDS you see there, ours is 500 milligram per liter. After relaxation can give it up to 2000, whereas in this case the TDS is given as 1000 milligram per liter. Right? And then here also you can see, and all the bacteriological quality parameters you see, they should fecal coliforms and coliform organisms. If we take a 100 ml sample, they should be nil, but only in the treated water pipe supplies, there can be small amount of coliform organisms. They are permitted because these treated water pipes, they usually contains some residual chlorine that will take care of these coliform organisms. And now for construction purposes, water is used mainly for curing. So this is standards based on IS 456 2000. And these parameters are there: organic matter, inorganic matter, sulfates, chlorates, suspended matter. They are prescribed under IS 456 2000. And the test procedures and all, they are given in IS 3025, part 18, part 24 and all. The organic matter is around 200 milligram per liter. It should not exceed. Inorganic, it means nothing but the sealed sand, etc. It should not cross 3000 milligram per liter. Sulfates, 400 milligram per liter. Chlorides, you can see here, RCC, 500 milligram per liter, and 2000 milligram per liter for PCC. They may cause some sort of a corrosion. Suspended matter, you can go up to 2000 milligram per liter. There are some values for pH, acidity and alkalinity. pH should not be less than 6. And acidity and alkalinity, the limits, they are given in terms of the titrant for using a 100 ml sample. So for acidity, when you are using the neutralization of sodium hydroxide, it should not be more than 25 ml when you take 100 ml of sample. Similarly, alkalinity, if you see, when you're using HCl as the titrant, 100 ml of water sample, it should not be more than 10 ml of that titrations. So this is how we normally look at. When here specific indicators are also mentioned. So using these, we are going to check the water is suitable for alkalinity or acidity. So now let us see the permissible limits of water quality for industrial use. Water quality for industry depends on a process requirement or requirements of the industry. So the major requirement of the industry is mainly we are using water and boilers to produce steam. When you're using water to produce steam in the boilers, you're heating at high temperatures. So then that water should not have high amounts of hardness or TDS. Otherwise, is going to have a scaling problem on the inner walls of the boiler and the connected pipes. So that's why many of the industries generally use demineralization process or ion exchange process to reduce the hardness in the water. Another important purpose used in industry is a cooling purpose. The hot waters which are coming out, steam or water coming out, it should be cooled indirectly. They are going for cooling purpose. But water quality used for cooling purpose need not be of high quality. But when you are using the water for industrial process as a raw material, so there are certain requirements of these quality parameters. Otherwise, they will interfere with the quality of the product. Let us see some of the industries and specific water requirements in that industries. For example, you take a tanning, the turbidity should not be more than 20 NTU. Total hardness as calcium carbonate, it should not exceed 135 milligram per liter. Alkalinity also should not exceed 133. pH should never be going beyond 8. And then color permissible up to 20 under cobalt scale. And other parameters as per potable water standards. In the textile, if you consider, there are different options under textile making. You have general method, and then the dyeing section, and then wool scoring, cotton bandage. Here also the permissible limits are given. And other than whatever is prescribed here, the remaining parameters must be as per potable water standards. And pulp and paper, if you see, there are two different processes which are mainly used. One is a Kraft process and soda and sulfate process. And here also you see turbidity can be slightly higher, up to 50 to 25 ATU. And total hardness is less than that of tanning, 100 milligram per liter. And then TDS, you can see 200 to 300. And iron or manganese should not be more than 0.2. and color can be relaxed up to 10 to 15 color units, cobalt scale. Remaining are as per the potable water standards. So like this, we are having different permissible limits for these parameters for different industries. That should be met before the water is used for actual processing of the product. And now use-based classification of surface waters in India. This is another thing which is being followed in India. So there are 5 different categories of water classes. Class A, Class B, Class C, Class D, Class E. Class A means the water source is a drinking water source without conventional treatment, but after disinfection. In such a case, only disinfection is provided, no treatment is there. So total in coliform organizations would be less than 50, and then pH 6.5 to 8.5, DO more than 6 milligram per liter, BOD should be less than 2 milligram per liter. Generally, we go for outdoor bathing, organized by so public guards. This is nothing but public guards. Their coliform organisms, it should be 500, less than 500 per 100 ml, and then DO should be more, and BOD again, upper limit is 3 milligram per liter. After conventional treatment and disinfection, you can see here, when you are using that water, this is a raw water quality. Remember this is a raw water quality. This will be treated to the as per the IS 10500, right? So up to 500,000 units of total coliform organisms or MPN per 100 ml is permissible, which can be treated to nil through disinfection and other processes. And at any point of the time when the source is used for drinking, the DO should never be less than 4 milligram per liter. If it is less than 4 milligram per liter, pure anaerobic conditions are there, and that water is highly contaminated with the contaminating sources, and anaerobic conditions are totally developed in that area. So that type of water should never be taken into consideration. And again, BOD upper limit is 3 milligram per liter. So like that, we are having standards for wildlife and irrigation, industrial cooling, and controlled waste disposal. So only thing is here, when you're using water for irrigation, boron is also to be considered 2 milligram per liter maximum. And sodium absorption ratio, so this is the value normally taken, the relative availability of sodium with respect to calcium and magnesium. This value should never be higher than 26 units. What will happen is more than 26 means that water is more saline in terms of sodium, and that that will make that land infertile. So the lower values of SAR are highly acceptable. Less than 10 is the best possible for irrigation. And 10 to 18 and 18 to 26 and beyond 26 means highly saline. And electrical conductivity is also there. Maximum value should never be less than, it should not be more than 2250 millimoles per micromoles per centimeter, right? So this is all about the different water quality standards followed in India, and we also discussed about the standards prescribed under WHO, right? Thank you.